Hello everyone, welcome to yet another video on integration. If you're new to this channel, please support us by subscribing and inviting friends to subscribe. Sharing these videos with friends, it will help us grow the channel and give us the ability to generate many more videos. Our first integral in this one is the integral of dx all over e power x plus e power minus x all squared. We are to integrate this one. Now, I invite you to stop this video and try attempt this question here and then come back and let's look at the solution and see if we get the same solution. The approach on this one, if you look at the expression in brackets, if you differentiate this, it's going to be e to the power x minus e to the power minus x, which is not present in the numerator, which means we have to do something. So our approach is as follows. Going on to our first page, page 1. Our first integral, it's the integral of dx all over e to the power x plus e to the power minus x, and we're squaring the whole of this expression. Now, the approach would be to look at e to the power minus x and rewrite it. So here is my second step. It's dx in the numerator. In the denominator, we have, watch this, e to the power x, if you like, over 1. Let me use square brackets now. Plus this expression here, you'll agree with me that it's 1 over e to the power x. And we have to square the whole of this expression. Now I'm going to look for the common denominator here, the LCD. You will agree with me that it's just e to the power x. I'm simplifying the expression inside the brackets. So my next step would be the integral of dx in the numerator all over this part here. You'll agree with me that the LCD is just e to the power x. And then we take 1 into e to the power x. The answer is e to the power x multiplied by e to the power x is e to the power 2x. Remember, we add the powers when the bases are the same. So we take this one into that. The answer is 1 multiplied by 1. It will be 1. This is what we have in the denominator, and we have to square that. Let me repeat what I said here. The lowest common denominator is just the product of e to the power x and 1. So 1 into e to the power x, the answer is e to the power x, has to multiply with the numerator. So we're basically saying e to the power x times e to the power x, it must be e to the power 2x, because we have to add the powers when the bases are the same. Remember, laws of exponents. Right, now I'm going to have to remove the brackets. Perhaps just keep the brackets in the numerator of our denominator, and then e to the power x, we have to square that. It will be e to the power 2x. Taking us to page 2. I'm spacing this work out so that you clearly see what is going on. Page 2, I'm saying that integral is going to be equal to the integral of dx all over. Watch this one now, how I'm going to change this. E to the power 2x plus 1, e to the power 2x plus 1. I'm going to say this squared all over e to the power 2x. Remember, when you square that one, e to the power x, it becomes e to the power 2x. Now, I'm going to rewrite this. So this is equal to the integral of, watch how I'm going to write it, 1 all over. And I'm going to rewrite this. Keep this one the way it is for now. E to the power 2x plus 1 all over e to the power 2x. Remember, that has to be squared. And then we have dx out here. Now this part here, you'll agree with me that it's just this goes up and that comes down. Remember, 1 divided by this, we are reciprocating this one basically. So the answer is e to the power 2x all over e to the power 2x plus 1 all squared. And then we have dx. At this stage, I'm going to rewrite it further in our next step. Watch this now. 1 all over e to the power 2x plus 1. I'm going to have to say square this times e to the power 2x dx. There's a reason why I'm combining those two. You'll see it in my next step. In my next step now, I'm going to let u be equal to e to the power 2x plus 1. So this is an advanced case of u substitution now, coming up after manipulating our original integral, taking us to page 3. So now at this point, let me move this one down. Right, I'm gonna now let let me put this one in nicely like this. I'm now going to let u be equal to e to the power 2x plus 1. This expression inside brackets there. Differentiating both sides implicitly, if you like, du is going to be equal to, remember derivative of this is going to be derivative of chain rule there. Derivative of e power 2x is e power 2x multiplied by derivative of the power, which will be 2 e to the power 2x, and then we have to say dx. Now we have to divide both sides by 2. The reason why we have to divide both sides by 2 is because if you look at this part here, it doesn't have 2 there, so we have to divide both sides by 2. So dividing both sides by 2, we have du all over 2. This equals e to the power 2x dx. Fantastic. So that's the first equation we obtained from this one. The second equation we obtained from this one would be to solve for x if you want, but I can keep it the way it is for now because we let's not try to make matters complicated here. I can keep it the way it is for now, and then we move forward. So moving forward, that integral changes to, this integral now changes to the integral of 1 all over. Remember, in the denominator now I'm going to have u squared there, 1 over u squared times, instead of e to the power 2x dx, I'm going to have du all over 2, like that. Taking half out because half is a constant, so we have half, and then we have, watch how I'm going to rewrite this. It's going to be e to the power minus 2 du. Now I'm simply going to apply power rule here because we have e to the power minus 2. I'm going to have to apply power rule, which basically says I have 1 over 2 here, and then I have u to the power minus 2 plus 1. I'm going to divide that by minus 2 plus 1. Remember the power rule, what it says, but I must say plus c because this integral here doesn't have limits of integration. It's an indefinite integral. Now let's simplify this part here. Remember this is minus 1, and that will be minus 1 as well. Taking us to page 4. So on page 4, this is what we have. Page 4, we have the following information now. We are basically saying this is going to be equal to 1 over 2 u to the power minus 1 all over minus 1 plus c. Rewriting this part, you'll agree with me that it's minus 1 over 2 times 1 over u power 1, obviously, plus c. What is the value of u, or what is the relationship between u and x? If you check here, u is actually e to the power 2x plus 1. So I'm going to rewrite this 2, watch this, minus 1 all over 2 open brackets e to the power 2x plus 1, like this, and then I'm going to say plus c. So that is the final solution to the first integral in this video. Let me remind you, the first integral, like I said, stop these videos and come back and check if your answers agree with mine. This is our first integral, looking very intimidating. If you did not work on this part here, it would be very difficult to evaluate this one. All right, moving on to our second integral in this video. Here is integral number 2. There you have it. We are to integrate dx all over 1 plus sine x. Again, if you differentiate the denominator, it's going to be cos x. Derivative of 1 is 0. Remember, 1 is a constant. But derivative of sine x is, with respect to x, is cos x. And we don't have cos x in the numerator, which means we have to do something about this before we can think of u substitution or any other technique for that matter. So, second integral, and this is on page 5 now. Page 5, the integral number 2 is dx all over 1 plus sine x. So what I'm going to do here is to take advantage of what we call conjugates. Now, conjugates work by using a simple principle we call difference of two squares. Let me just remind you on that one. So when we talk about conjugates, we're basically saying a squared minus b squared. The answer is, as you would recall, a minus b and then a plus b, like so. These two are what we call conjugates. If I have one, I need another one to come to difference of two squares. So if you see 1 plus sine x, basically we can have the conjugate of that is 1 minus sine x. So that's the special one coming up that is famous in my videos, if you'd recall. So I'm going to write this as 1 all over, watch this, 1 plus sine x times, there's your special one coming, 1 minus sine x all over 1 minus sine x. Let me put these in brackets now, like so. Don't forget dx there. Now, if you look at these two terms, if we combine 1 times the numerator on the other side here, it's going to be just that one. And then these two together form what we call difference of two squares. So this is the integral of 1 minus sine x all over. Watch this. Let me keep this one the way it is for now. 1 plus sine x and then 1 minus sine x. And then we have dx there. Now watch something here. This form here is this form here, as you can see. It means I need this form to get to the answer. So I'm going to have to say 1 squared minus sine squared, which is basically 1 minus sine squared in the denominator there. Taking us to page 6. Page 6. So basically I'm saying that integral is the same as 1 minus sine x all over 1 minus, if you like, 1 squared minus sine squared x dx. And obviously you agree with me that this is the integral of 1 minus sine x all over 1 minus sine squared x dx. Taking you back to trig identity, sine squared of x plus cos squared of x equals 1. If we solve for cos squared of x here, you're going to get cos squared of x is equal to 1 minus sine squared of x. This one here is what you see there in the denominator. So I can replace it with cos squared x. So our integral changes to the integral of 1 minus sine x all over cos squared x, and then I have dx. Now, if you remember, at this stage, I'm going to use what we call term-wise division. So this cos squared x will divide into 1, and that, of course, respecting the minus sign there. And then I'm going to have to distribute this integral sign and dx. The integral changes to the integral of 1 all over cos squared x dx minus the integral of sine of x all over cos squared x dx. Now, let's work on this and that there. On page 7, we have the following information. Page 7, we have the following information. Remember, 1 over cos is secant, and 1 over cos squared has to be sec squared. So that is basically the integral of sec squared x dx minus the integral of, look at how I'm going to rewrite sine x over cos squared x. Let me move this one down. Right, I'm going to rewrite this expression here as follows. 1 over cos x times sine x over cos x dx. So I have divided, I've actually broken down the cos squared x into cos x times cos x. And of course, 1 times that is just that expression there in the numerator. Now, why am I doing this? Because the integral of secant squared is just tan x. And then minus, here I have the integral of sec x tan x. Remember, 1 over cos is sec, sine over cosine is tangent dx. And the integral of sec tan is just sec. So our final solution then is tan x minus sec x, and then I have to say plus c, because we're dealing with an indefinite integral here as well. So this is how you go about these two integrals. I am going to stop here in this video, a short one, but yeah, if you have questions, please pose those questions in the comment section, feedback in the comment section. We truly value your feedback. All right, I'll see you in the next one.